Hello everyone, my name is Lijie from University of Nottingham, Ningbo, China. Today I will present our paper titled Differential Effects of Virtual and Augmented Reality on Social Presence and Engagement in Collaborative Gaming for Unfamiliar Users. And in everyday life, working with strangers is actually very common in classrooms, project-based learning, and professional training. However, collaboration with unfamiliar partners often feels difficult. This is mainly because there is no trust at the beginning. People need to quickly build shared understanding, agree on roles, and coordinate actions. When this happens under time pressure, communication can easily break down and it becomes hard to stay focused and engaged. Since this challenge happens, one major potential of XR lies in its ability to support collaboration. In practice, XR systems have already been used in many collaborative settings. For example, prior work shows that mixed reality can support ad hoc on-site collaboration, team-based XR training can improve collaborative learning outcomes, and collaborative VR games can enhance engagement through shared problem solving. So, XR clearly has promise, but how it supports collaboration still matters. However, when we look at the direct comparisons between AR and VR, many existing studies focus on single user experiences or on teams who already know each other. That's not how many real collaborations work, especially in classrooms or ad hoc projects, where people often start as strangers. More importantly, AR and VR involve fundamentally different trade-offs. VR can create strong immersion and deep task focus, but it reduces real-world social cues and may increase discomfort. AR preserves face-to-face cues and situational awareness, but it can split attention between the physical world and virtual content. So this leads to our core question. How do these modality-specific trade-offs shape social presence and engagement when collaborators are unfamiliar? So based on this gap, we propose two research questions. First one is, how do level of social presence and task between AR and VR for unfamiliar users performing collaborative engagement differ among tasks? And the second one is, what challenges do unfamiliar users perceive in social interaction during collaborative gaming in AR and VR? Before diving into our study, let's step back and looking at the big picture. Across prior work, one thing is very clear. AR and VR are not the same experience. Even when the task stays the same, changing the modality can change how present people feel, how engaged they are, and how they evaluate the experience overall. Another key observation is that these outcomes are highly context-dependent. Results differ across AR, VR, and controlled lab settings. Taken together, the literature suggests a simple point. Modality itself matters, and AR and VR should not be treated as interchangeable when studying collaboration. When we move from individual experience to collaboration, AR is more often associated with stronger coordination. Because AR is grounded in the physical world, collaborators can directly see each other's bodies, gestures, and actions. This supports mutual awareness and face-to-face interaction. However, this strength comes with a cost. So in AR, users constantly divide attention between navigating the physical space and interacting with virtual contents. As a result, while AR supports coordination, it can also increase attentional load and coordination effort, especially when multiple cues compete for attention. In contrast, VR collaborations tend to emphasize immersion and focused engagement. By placing users inside a fully virtual environment, VR can promote absorption and flow, helping teams stay deeply focused on the task. At the same time, social interactions change. In VR, collaborators rely on avatar-mediated cues such as gaze direction, gestures, and movement. These cues can support social presence, but they are not the same as real-world interaction. So, while VR is effective for deep task engagement, it may limit subtle nonverbal signals and make interpersonal synchronization more challenging. So, to directly test these trade-offs, we built the same escape room collaboration in both AR and VR and compared unfamiliar pairs. We choose an escape room format because it naturally combines time pressure, shared risks, and interdependence. This makes it a realistic yet controlled setting for studying collaboration. The core design principle of this game is asymmetric collaboration. In every minigame, players cannot succeed alone. Each player has access to different information, positions, or visual perspectives. Across the 3 rooms, we systematically varied information, positional, and visual asymmetrics. This design forces players to communicate, coordinate actions, and make joint decisions. Then, we conduct a between-subject experiment comparing AR and VR condition. We recruit 52 university students and randomly paired them into unfamiliar teams, resulting in 26 two-person groups. Each team experienced either the AR or the VR condition. The procedure was structured and consistent. Participants first complete a short tutorial, then play the escape room game for about 20 to 30 minutes. After a short break, they complete questionnaires and individual interviews. The full session lasted about 1 hour. We used a mixed method approach, combining standardized questionnaires on engagement, social presence, and comfort with in-depth interview data. This allows us to compare AR and VR under identical task conditions. Now I will briefly summarize the quantitative findings. First, VR produced stronger task absorption. Participants in VR reported higher sensory and imaginative immersion and much stronger flow states. This suggests that VR pulled teams deeper into the game experience. Second, AR supported better coordination-related experience. AR participants reported higher competence and higher behavioral involvement and mutual attention. This indicates stronger real-time monitoring and coordination with teammates. Third, these benefits came with costs. VR was perceived as more challenging and led to higher nausea and slightly higher accumulator discomfort. These comfort effects should be interpreted as cautiously, as locomotion was not fully matched across conditions. To better understand these patterns, we analyzed the interview data. Participants described distinct collaboration styles in AR and VR. In VR, collaboration was often described as task-focused and goal-oriented. Participants felt immersive and trust their partner's contribution, but social cues was limited and had to be interpreted through avatars. In AR, collaboration felt more socially invisible. Participants continuously monitored their teammates' actions, using face-to-face cues such as body movement and gestures. However, this also introduced challenges, including self-conscious, emotionally sensitivity, and distractions from the physical environment. Together, these accounts explain how and why the quantitative differences emerged. So our key insights is that AR and VR support collaboration through different pathways, rather than being simply better or worse. VR supports collaboration through deep immersion, but relies on mediated social cues. AR supports collaboration through mutual awareness and coordination, but increases attentional and emotional demands. Importantly, social visibility is a double-edged sword for unfamiliar teams. It can improve coordination, but also amplify evaluative pressure and distraction. Finally, physical comfort directly constrains collaboration and should be considered as the condition level. Overall, our findings revolve a clear trade-off. VR prioritizes deep task absorption, while AR prioritizes mutual awareness and coordination. Our work makes two main contributions. First, we provide a systematic comparison of how unfamiliar pairs collaborate in AR and VR. Second, we use a mixed methods approach to identify key social and interaction challenges in both modalities. There are several limitations. Our sample consisted mainly of university students. Locomotions were not fully matched, and we rely mostly on self-reported measures. In future work, we plan to make better match locomotion and add objective, behavioral, and performance metrics, and extend this work to broader task and applied training context. Well, and that's all. Thank you for listening.